Welcome to the laboratory sessions of the Computer Networks course. So the laboratory sessions are called TCP IP socket programming in C, where we will be using C programming language to create and play with sockets. So the first laboratory session is going to be simply about introduction, where first I will introduce myself, and then I will quickly go through what we will be covering during the next laboratory sessions. And then I will briefly introduce the basic concepts, the fundamentals of TCP sockets. Okay, let's start. So my name is Kobil John, or you can simply refer to me as Kevin, and I will be your lecture assistant. I will be responsible to create your homeworks, and I'm not sure who's going to be grading. So the location of my office is in High-Tech Building, room 1008, and my email is, as you can see here, kobiljohn@nsl.inha.ac.kr. That is the preferred way of communication, and otherwise, if you have some urgent deal, then you can text me using KakaoTalk and by this number. And office hours are going to be on Monday and Tuesday, from 5 p.m. till 6 p.m. And if you have any questions, please inform me before visiting the office, please. Okay, let's get going. So as I told before, the title of the laboratory sessions are TCP IP socket programming in C programming language. And the duration of the laboratory sessions are going to be 2 hours per week, and which means for credit hours, 2 hours of lecture plus 2 hours of lab. Also, the first 2 weeks, according to the INHA University's main office, the first 2 weeks are going to be conducted online using the video lectures. So please bear with me. After 2 weeks, we're going to be having regular laboratory sessions. The assessment section related to lab. We have homeworks, which are going to be covering 10% of your overall score. And we will have 10% attendance. That includes the lectures plus laboratory. Overall percentage of the scoring is going to be 10%. And the number of homeworks are still unknown. It's going to be determined starting from April, I believe. And usually in the computer networking laboratory sessions, we have bonus point tasks, and it can be defined after 2-3 weeks, so it's not clear yet, as I noted here. And if there is going to be any bonus point tasks, I will announce during the laboratory sessions, hopefully when we meet after the first 2 weeks. So let's jump in the content of the laboratory session. The basics of the socket programming in C. So let's first try to understand what is network programming, or what is socket programming. Socket programming is actually a subsection of computer networks overall. It can be understood as a practice to computer networks. The network programming itself is well known as socket programming because the computer network is completely based on sockets. So whenever we want two computers to interact with each other, we'll have to be working with sockets. We'll have to deal with sockets because that's the mean of communication of two computers, of any kind of devices, not just computers. It can be phones, or it can be any IoT device. They will be creating sockets. So let's try to define it. Building a program that receives and transmits data between two or more computers by means of a network. Simple understanding of a socket. Socket is provided by default by any operating system that the devices operate on. It can be Android, it can be Windows or Mac OS, any kind of operating system that they support the generic socket type, and that is based on top of TCP and UDP protocols that we will be covering later on. So let's not dive too much into details, and let's try to be as abstract as possible for the first laboratory session. And so the sockets provide a high level of abstraction. That means it provides a very simple usage for programmers, so that the programmers are going to be us. We will be the programmers that are going to be working with sockets, so that we don't have to worry about the underlying physical and software details of networking that actually you will be covering during the lectures. There's a lot of things that are going on whenever, let's say, you try to send a message using, say, KakaoTalk. If you try to send a message, a lot of protocols are applied, and just simply to transfer one string, one message to the destination machine, a lot of physical operations are also being performed, and that will be covered during the lectures, also in the laboratory sessions as well. But we don't really have to worry about it during the socket programming using C programming language, because the default provided by operating system, such a thing called socket, is going to be handling for us. So that is a very of a high level of abstraction. So the first thing that we have to know before starting to program is the 5 must-know fundamental details of the socket programming in C. And please don't fall asleep. It is not going to be boring, but I know I'm a little bit monotonic, but I will not be like that once we meet, hopefully. Okay, so let's jump in. So the first thing is socket itself. The first thing is creating a socket. That is basically the first step before communicating, before two devices start to communicate. They have to create a socket. And as we know already, socket is a means of communication of any kind of device, right? So the TCP socket, basically, if we try to think about what the TCP sockets are, TCP sockets can be compared to a phone in real life. So whenever you try to talk to someone that is not nearby you, then you're going to have to call them, right? And then you will need a phone to communicate with that person. So you will be communicating with that person by means of a phone. Exactly in that way of thinking, from that point of view, devices need sockets to communicate to other devices, to communicate with other devices. So that solidifies the sentence where I said devices communicate by means of socket. To perform network input-output operations, the first thing a process must do is call a socket function to create a specific type of socket by specifying the type of the communication protocol and the protocol family, and etc. So let's try to take a look at this very simple method. So we don't have to worry about all the details of it, just take a look at what it provides. It's provided by the default header file that is basically provided in the Linux devices. Apologize for the noise. So this function is within this header file, so whenever we want to create a new socket, then we will have to include this header file. And then we can call this function that contains 3 arguments, which are domain, type, and protocol. And for now, we can be just focusing on the type and protocol. Like here, we said there will be communication protocol desired and protocol family, right? and there are a lot of protocols like for now just like TCP and UDP. Let's try to consider them. Okay. The second step is binding the socket. So we have already created a socket by calling this function of socket, right? And then where we specified the domain, and then the type of the socket, and then the protocol, which kind of protocol it uses, the TCP or UDP. And then now we have to bind that socket to a specific address, to a specific port in our device. So let's try to understand what binding is. So now we have let's try to come back to an example of a phone. When we try to talk with someone, when we try to call to someone, so before trying to call to someone else, we have to register that a phone number to the phone. We have to have a phone number in order to be able to call to someone else, in order to dial another phone number from our phone. So basically, binding the socket means registering a phone number to your device. And when you create a socket, when you specify the type and the domain and the protocol type, you actually still don't have a complete address till your device. You'll have to specify it yourself, because your device can have a local address, a local network address, or a public IP address. So there are a lot of addresses that one device can have. Also, all devices contain a lot of ports that you can use, and then you'll have to specify an IP address plus the port number so that you could communicate with other devices using that address, plus other devices could also communicate with your device using the address that you specify. So before starting to transfer data, you'll have to provide a complete address. Also, you'll have to specify a port. So we bind a socket to a port. So that's how you can understand. Phones do not have a phone number at the beginning when you purchase them. So that means you can't make phone calls. So the first thing we do is we register a phone number. And for that, the process is called, the process of allocating port number is called binding. In order to bind a socket to a process, to a port, we will be calling this little function that has these three parameters called socket file descriptor, and then the address, and then the address length. And also, like we said, it's basically binding a socket to a device. In order to be more technical, we will be binding a socket that is inside your process to an address that contains both your IP address and a port number. And the last parameter is provided by default. That's just the size of the IP plus port number, IP plus port address, the size of the structure. So, like, just to connect the dots, the first thing that we did was creating a socket, and now the second thing is calling this function to bind that socket to an address. So now we have a bound socket. That means we have a phone number with a registered phone number. We have a device phone that already has a registered phone number. So that means after this step we can make phone calls. And from a computer network's point of view, binding a socket means that indicates that it is ready to receive and send information. After this step, we should be able to communicate with other devices. So that was the second step. Now, the third step, the listen step. So usually when devices communicate with each other, one device has to be listening. That means one device has to be open to connect to other devices. That role is usually played by a server in a TCP communication, usually we have a TCP server and a TCP client. So from the beginning, the TCP socket creation and TCP socket binding, we were actually talking about a TCP server part, and now the listen is also the same TCP server part. So the action of listening for connection requests is made by the TCP server. And in order to not to confuse you, I will go back to this slide to explain you one more thing. So 5 must-know fundamental details of the socket programming in C requires deep understanding of creation of TCP server socket, and those 5 steps are going to be covering the TCP server functionality. And after we know the basic steps that we have to make in order to create a TCP server, we can easily connect to the TCP server by making just simple 2 steps of 2 function calls on the TCP client side. So the TCP client side is not actually difficult. A little bit more complex side is the TCP server side. So let's come back to the listen part. Listening for connection requests. So when we are already ready to connect to other devices, we start listening to for TCP client's connection requests by making this function call. Let's try to read this definition. Identifying a bound unconnected socket means identify the connection requests. The process of converting an unconverted socket into passive socket indicates that a kernel should accept incoming connection requests directed to this socket. That means after calling this listen, the TCP clients will be able to make connection requests. And before, when we had, let's talk about the phone example. Before, when we had our phone and when we registered a phone number, we still were not accepting other phone calls, the phone calls to our phone. And now we will have to explicitly make this function call so that after this, other devices could make phone calls to our phone. That's basically what it means. The process of converting an unconnected socket into passive socket. That means an unconnected socket can be considered in our process as a connection request. Okay, let's jump to the 4th step, the 4th element of TCP socket creation. The next step is accepting an incoming connection request. So at this step, we already must have incoming connection requests from TCP clients, and at the TCP server part, we will be accepting those socket connection requests, socket creation requests. And in a technical language, it means transition of the connection request from the listen method, from the passive socket, into an actual socket. Means accept the connection request. That socket is going to become active from passive. And after we accept an incoming request, the socket is going to be created automatically. That socket is what we were targeting to create. That was our goal. That was the means of communication between 2 devices. That means after this step, we will have that door open. We will have that path from which we can send the data, transmit the data. So the data can be finally transferred between the 2 nodes. So let's take a look at this function, accept. Still we have that socket file descriptor and the address and then the address line. So it's basically the same thing as the binding step, but instead of the function name is accept. So we already have that socket. So what we'll have to do is just give that socket file descriptor as an argument, and this accept function handles all the rest of the things that the usual TCP does, like 3-way handshaking, that you will be covering in lectures, and hopefully I will also explain in laboratory sessions as well. Okay, so after this step we have the socket. So now let's take a look at the fifth step. Actually, the fifth step is just making logical steps from the four previous parts. Actually, we have the first step here, but let's just come back to this step and let's try to understand what we did. Let's try to connect the dots. The first thing was creating the socket by making a socket function call. And then the second step was binding that socket. Just I want to make sure that you pay attention because this is a very important part. So you have to know this sequence. You have to memorize the sequence of those function calls, or at least you have to memorize the meanings of those function calls. So the first thing is we create a socket, and then we bind that socket to a port. Not just port, it's complete like overall address, an IP address plus port. But why we wrote port here? Because port is the final, the most specific address to a process. It can't be more simpler address than port. It doesn't get more simpler than that, but more specific address than IP address is a port. Port is a door to a process. Basically, from your process, you will be opening a door to another process, and that door means a network. So when you specify a port, that means you have a door to another process. So the second step was binding that socket into a port by making a bind function call. And I apologize for this typo. It's actually step number 3, and I could actually spend some time to stop this video and then change this text, but it takes a lot of time, and I apologize for the inconvenience. So the step number 3 is listening for incoming connection requests and identify ones by making a listen function call. And let's try to remember what the listen was doing. Listen was actually it was converting an unidentified sockets into unconnected sockets into passive sockets. That meant other computers after listen will be able to make connection requests, right? And so the fourth step was accepting those incoming connection requests after the listen step. So that means if you don't bind the socket to a port and then start listening right after creating a socket, it won't work. It simply won't work. Without the step number 2, the listen will not work. Or without the step number 3, accept will not work. Or if you don't create a socket, of course, then the rest will not work because you have to modify the socket during those 4 steps. And actually, I have uploaded these source files where we can practice not practice, but just compile and see how the socket creation works. And you can download it from the Blackboard from learn.inha.ac.kr. Okay, so now let's jump into the fifth step. That fifth step is actually not the TCP server part. The last part is the TCP clients part. That was the step when we established a connection. So somehow the TCP client should be able to make a connection request. So that connection request is made by calling a connect function call. So client basically also calls or first creates a socket, but without doing all these binding, listening, accepting steps. It jumps from the step 1 to connect function call. So after those 4 steps, the TCP server is already listening and waiting for our connection requests. So the TCP client, all it has to do is create a socket and connect to a specific address. And it's like you can understand the connect function call as a dialing to a specific phone number. And the implementation of the requesting to connect is very simple, unlike listening and accepting sockets like I told before, a little bit before. To make a connection request, you just have to specify an address of the TCP server, and that's all. It will create the socket automatically, and if the server is not listening, it will generate an exception. So let's take a look at the function, how it looks like. So the connect function accepts the socket file descriptor as its first argument, as its first parameter, and then the address, the destination address where you want to which you want to connect to. That will be the TCP server's address, which has to contain an IP address of that server plus the port number. Whew. Okay, we're good to go. We just covered the five fundamental details of socket programming. Okay, so now we will be moving on to installation of the GCC compiler. That is GNU-C compiler, which we'll be using to compile our source files and then run. So the method of running Linux-based programs is I would paraphrase the sentence a little bit differently. Method of running your text file is by compiling using the GCC compiler and then running the compiled version of your text file with these following two steps. So you just specify, you just write in a command line GCC and then define and then write your text file name that will have an extension of .c, and then you'll say -o. That means the output file name is hserver. So the output file name is the executable file that will be compiled and generated using your source file. And then you will be running that executable file by just putting this a little dot slash the name of your executable, and we're good to go. So before all that, let's try to install the compiler itself, because I believe you don't have that compiler, and let's try to learn how to install it. So to the socket programming lab sessions are going to be on a Linux environment, and the personal computers in high-tech building are not running Linux devices, so we will have to install a software that will provide us in a Linux environment. So the CYGWin software can provide us a Linux environment and compile the source files as if the source code is being compiled in a Linux environment. So that's why the text was Linux based. Okay, so now let's try to install and download and install the software called CYGWin. For that, we will first download a software called CYGWin and then install it. And during the installation, we'll make sure to install these two little modules that are called GCC and G++ compilers. And then, oh god, I apologize for those typos. It's actually the number 3. So the third step is installation of an editor by your choice. So it's completely up to you where you want to be typing in the source files. The beginning, I believe in the beginning 2 or 3 weeks you are not going to be writing any source files, but you will be only reading and trying to understand how the sockets are created, how the connection is established. But anyway, if you want to understand the code and if you want to play with it, then you will need to install an editor, because it's difficult to write code in Notepad. So my personal choice is Notepad++, because it gives you highlights. Oh, let's just stop advertising and let's just try to install the software, CYGWin. So in order to download CYGWin, you'll have to Google download CYGWin, either Google or Bing. So just going to the first search result, where you should see this little link, setup x8664 exe file. just download it. And if you're running a Linux device, then you don't have to download it, because you'll by default have this Linux environment. And continue on from the third step. So let's save this application and run it. Okay, I will be simply running it, as you can see. Okay, so we will have our web installer opened, and then we just have to click next, and we will be installing from internet. We'll click next and simply next. Still next. I hope it won't take too much time. You can feel free to click any of it, so I'll just go ahead and click the first URL. It will download all the necessary elements. Oh, it's much faster than I thought. And then we will be expanding this drop-down menu and click this full option. And here we will search for GCC, and then we will have a lot of elements. Oh god, I believe it's GCC, GCC G++, and GCC Core. So we have to install these two modules by picking the version of installation. And also we have to install G++, and here too GCC G++. Oh, it's already being installed, so we are good to go. So we can just click next, and just so that you could see again. Oh, of course you can just it's a video, so you can see any minute of it. Anyway, so we just picked this GCC G++ and GCC Core. As you can see, the GCC G++ as well. And then we are clicking next. After a little bit of time, we will have our software CYG-Win in our computer. All right. I really don't need it. It's still okay. So we have the CYG Win application ready to be run on our computer. So we have just installed and performed the second step. And before starting to compile and run, I will go ahead and install Notepad++ as well. And if you want to follow my choice, then you can also do the same thing. And the Notepad Notepad++. Oh, I apologize for the picture. Notepad++. So it's available by this link, notepad-plus-plus.org, and we can download the app by this link. I am not sure why my network is so slow. I believe I'm connected to a stable Wi-Fi network. Okay, let's download this installer and run it. The reason that I like this IDE is this little animal. I'm not sure what kind of animal it is, but I like it. Okay, create a desktop shortcut and run Notepad++. Okay, I will go ahead and open the source file that I shared with you. That is in the Computer Networks Lab 1. So these are the source files that I wanted to share, and I will go ahead and open them using the Notepad++. As you can see, it gives you the colorful view of the source files, which gives you a really good user experience in order to understand the code very easily. And let's now try to compile these two files that are called hello client and hello server. Okay. In order to compile the source files, please pay attention to these steps because these are very important. You will have to copy these two files into a folder that is located in your C drive that was created when you were installing the CYG Win application. Okay, the folder is located in your C drive, CYG Win folder, home directory, and or you can just simply type in the path from here. C drive CYG Win 64/home. So this is the folder where we will be copying our source files to. And now you will see the reason why we have to copy it. So let's try to open that CYG Win terminal. And once you open it, don't pay attention to this directory, you will be seeing, I am trying to zoom in, I'm trying to increase the font size so that you can see, okay. Hopefully you can see the font. Okay, I found the hotkey, Oops, okay. Okay, we are good to go. So here you can see a simple command line. This command line is actually a Linux environment that was created within your Windows computer. So here, if you try to run ls, that means list current directory. Okay. Oh, I apologize. This home directory is not the final directory where we wanted to copy our files to. The folder that's called Kevin was created after I opened the CYGWin application, the CYGWin folder, the CYGWin software. And when you open the CYGWin software, you will have another folder that will be your computer's username. And so this computer's username is Kevin, that's why it was created here. So the final directory is actually this one. So we just copy the source files into this directory where you will have a lot of like 4 weird files that we don't want to touch. Actually, these are the only files that we want to touch. And now when you when you type in ls, you will have the 2 source files listed here. So when we listed the current directory, so when you type in pwd, you will have this home Kevin directory. That means your present working directory is here, which is home Kevin. So basically what the CYGWin software does is it creates a virtual environment and virtual Linux environment for you. So let me just clear out this terminal so that we could see the compilation steps in a better way. So I will go ahead and open 2 terminals so that we can run a client in one of them and a server on the second one. So here on this terminal I will run the TCP server, and on the second terminal I will run the TCP client. So this one will be the client part and this one will be the server part. And before being able to run that executable, we have to convert the source files. And that step was explained right here. So we have to call GCC hello server.c, that was the file name, and then we have to specify the output name. So let's go ahead and type in that and see what happens. GCC hello server.c -o, and then say this server, and actually that was H server. Okay, I will just go ahead and name it this server. So now, as you can see, there is an application that was created inside that folder, and that is the application that we want to run. For that, in order to run, we have to type in /server. We don't have to just text that exe. And then we have to give a port, assign a port. Like, let's say it's up to you what kind of port to use. For me, I will just go ahead and use 9876. So when I click enter, the server is going to be already running here and then waiting for incoming client connections. So let's go ahead and compile the client part and then run that part as well. GCC hello client.c -o client. So now the client application has also been generated using the GCC compiler that just converted our text source file into an executable. And now we can go ahead and run that executable by giving an argument. So the client, now the server is listening to any TCP connection requests on the 9876 port, and the client has to specify which IP address to connect to and which port of that device to open its socket with. So first what we have to do is specify that we want to connect to this machine itself, and this machine itself means 127.0.0.1. That means the local host, myself. I want to connect myself to this process. When we said this port, in English language it meant I want to talk to myself, but to this ear. Let's say this is an ear. Let's say this port means an ear. I want to talk to myself, but to my left ear. And then instead, if we said not 6 but 5, that means I want to talk to my right ear, not this program. I want to talk with another program. So here we said 6, that means I want to talk to this program specifically. And now, when we click enter, you will see that the client received a message from the server. I believe it's actually an echo message. That means the client itself sent that message to the server, and the server echoed back to the client itself the hello world message. And now it's a perfect example of socket creation on the same machine. And as you can see and feel, hopefully the socket was successfully established by running the 4 must-know fundamental details of the socket programming, that by making these function calls where where the server has created a socket and bound it to a port and listened to connection request and then accepted a connection request when it was made, and then the client made a connection request. So those steps were successfully performed when we opened our server and when we opened our client. Thank you very much for your attention. I believe that will be it. And here you can see these outputs. And oh, okay. So we have a little bit more, but we're out of time. So please take a look at these as well, and I will explain them in the next slide, in the next section, lab session. Thank you very much for your attention. Hope to see you soon.